Welcome to this explainer. Today we're diving into a seriously mind-bending battle. We're pitting the catastrophic, unforgiving laws of astrophysics directly against the breathtaking, rule-breaking illusions of Hollywood. We're going to explore the horrifying physical reality of what a 10-second gravity loss on Earth would actually look like, and then uncover exactly how visual effects artists intentionally fake the physics to create cinematic magic instead. It's a fascinating collision of hard science and digital artistry.
So, the whole thing kicks off with one massive, awesome what-if scenario. What actually happens if the fundamental force holding our entire universe together just turns off? Just for 10 seconds. Now, it sounds like a really fun thought experiment, right? But it immediately pitches real-world astrophysics against what blockbusters absolutely have to deliver. Because, when directors want to show you zero gravity, they're looking for awe and wonder. They're definitely not looking for instant, horrifying obliteration.
Picture an IMAX storyboard for this exact scenario. You've got children playing in parks, and they just slowly, gracefully float upward. Rivers and oceans rise up into these enormous, shimmering, floating spheres of water. It paints this incredibly whimsical, family-friendly vision of a gravity-free Earth. You'd have hot air balloons drifting around, marine life swimming perfectly safely inside giant magical water bubbles. It's a completely serene environment. But, as we're about to see, the actual science paints a far, far deadlier picture.
So, here's our roadmap for today. 1. The 10-second dream. 2. The apocalyptic physical reality. 3. Faking physics for film. 4. Simulating the impossible. And 5. The devastating return.
Section 1. The 10-second dream.
In this cinematic dream world, everything unanchored just gently lifts right into the air. Cars gracefully drift safely away from the roads. Millions of colorful forest leaves float upward to form these beautiful green clouds. But most importantly, the Earth itself remains perfectly, solidly stable. The mountains are firmly attached, and literally the biggest risk to anyone's safety is maybe a flock of birds flopping around in confusion. It's peaceful, it looks photorealistic, and, well, it's completely impossible.
Section 2. The apocalyptic physical reality.
Okay, to understand what would actually happen, we need to talk about hydrostatic equilibrium. Basically, this is the delicate balance of forces that maintains the structural integrity of our entire planet. Right now, as we speak, gravity is acting like a giant vice grip. It's pushing down and countering the immense internal pressure of the Earth's ridiculously hot mantle and core. So, without this equilibrium pushing back, the Earth's stored elastic strain energy doesn't just sit there, it releases instantly, and it moves outward at the speed of sound.
Because our Earth is currently compressed by its own gravity, just turning that force off would cause the planet to elastically expand by up to 350 miles. 350 miles. Think about that for a second. The crust wouldn't just gently rise up, it would absolutely shatter into fragments the size of skyscrapers. This would trigger global volcanic eruptions and massive earthquakes as the entire planet effectively explodes outward into space.
Oh, and it gets worse. A lot worse. The atmosphere would instantly decompress right into the vacuum of space, which means the air pressure drops at the speed of sound. Remember those laughing children in the park from our cinematic storyboard? Well, unfortunately, this sudden, massive drop in pressure would instantly shatter the inner ears and lungs of literally all living organisms on Earth. Yeah, no one is laughing now.
And this nightmare scenario extends right into our oceans. According to the Clausius-Clapeyron relation, a sudden drop to zero ambient pressure means all exposed liquids would violently flash boil. The oceans would rapidly evaporate and then instantly freeze into fine ice crystals. That's a pretty stark contrast to those safe, shimmering liquid spheres that comfortably trap whales in the movies, right? In reality, aquatic life faces immediate suffocation and vaporization.
Section 3. Faking physics for film.
So to bypass this horrific reality, VFX artists basically have to become master illusionists. They use very specific software cheats to just override real physics. To stop the Earth from expanding 350 miles, they use a finite element method with rigid anchoring. They are literally locking the crust in place in the software. To stop the atmosphere from exploding, they use a non-divergent gas solver with boundary caps, which keeps the air density totally constant. And to stop the oceans from flash boiling, they use what's called a Houdini flip solver, artificially scaling up surface tension to maintain those beautiful, photorealistic but entirely fake liquid illusions.
Section 4. Simulating the impossible.
By applying a super precise, art-directed technical sequence, studios can completely bypass true physics. First, they start by giving mountains infinite mass attributes, meaning they won't budge an inch.
Next, they bring in agent-based AI crowd solvers. This makes the birds flap around erratically rather than just dropping out of a decompressed sty. Then, they deploy Embergen gas solvers with microturbulence to gently swirl those floating forest leaves. And the cars? They utilize rigid body dynamics, or RBD for short, to simulate the mechanical spring release of the suspension. That's what causes the vehicles to just gently bounce and drift up into the air.
Now, handling those iconic floating oceans, that requires a totally different toolkit. In microgravity, intermolecular cohesive forces suddenly become the dominant physical force. So VFX artists rely on actual reference footage of astronauts playing with water in space. Then they heavily amplify that exact effect using fluid implicit particles, or flip solvers. They use divergence fields to trap air bubbles safely inside the water and bidirectional fluid structure interaction solvers so that animated whales can generate incredibly realistic ripples as they swim right through a floating bubble of ocean.
Section 5. The devastating return.
All right, let's go back to reality for a second. At exactly t plus 10 seconds, gravity turns back on. The catastrophic recompression of the Earth's crust, as all that expanded energy snaps back, generates 3.3 times 10 to the 28th joules of kinetic energy. To put that into perspective for you, that is equivalent to 8 trillion megatons of TNT. This sudden gravitational slam would literally melt the planet's outer crust and completely sterilize the solar system.
So how exactly does Hollywood save their characters from a 45-kilometer-per-hour kinetic impact and massive, devastating tsunamis? Well, they use a virtual parachute. Specifically, they use a nonlinear gravity dampener with an S-curve interpolation over 2 seconds. This incredibly clever VFX cheat ensures that every single floating object lands softly. The giant spheres of ocean just merge gracefully back into their riverbeds with perfectly aesthetically pleasing cascades of water. No sterilization of the planet required.
As we wrap up this explainer, it really leaves us with a fascinating paradox to consider, doesn't it? We've just seen exactly how perfectly we can simulate a fake reality that completely defies astrophysics. But by substituting explosive decompression and flash-boiling oceans with shimmering water spheres and drifting leaves, how is this cinematic magic permanently altering our understanding of real-world science? It's a fascinating thought to leave you with. Thanks so much for joining me on this explainer, and remember to always keep questioning what you see on the screen.